All right, that actually helped remind me to actually start recording today's lesson. Otherwise, I would have almost forgotten. All right, recording is going. Yep, looks good. All right, so meter is for length, for measuring out stuff. It's the metric system or the SI unit that we use for it. So we're not using inches or feet or miles anymore. We're using meters and kilometers and millimeters, all that good stuff. So like I was saying, instead of being a weird conversion of like 12 inches is a foot, 3 feet is a yard, 1,200 something yards is a mile, and meters and kilometers and millimeters, everything is based on tens and hundreds and thousands. So 1 kilometer, for example, is exactly 1,000 meters. So if you took 1,000 meter sticks and laid them end to end to end to end, they would measure out to exactly 1 kilometer. So kilo is a prefix, a start of a word that means like 1,000. So 1 kilometer, 1,000 meters. The meter itself, we can break up into smaller chunks. So if we broke a meter up into 100 equal sized pieces, each of those pieces would be 1 centimeter. So there are 100 total centimeters and 1 meter. We can also break a meter into even smaller chunks, into millimeters. So there are 1,000 millimeters in 1 meter. So if you look at our little meter stick from the last page, there we go. These big numbers here represent our centimeters. So this picture is approximately 9 centimeters long. But the smaller little dashes in here are millimeters. So each centimeter is 10 millimeters. So in between this number 1 and number 2 right here, there's going to be 10 of these little millimeter dashes. So in our meter stick, if we measured it by centimeters, we'd have 100 centimeters going all the way to the end. If we measured it in millimeters, it would be 1,000 millimeters. There's 1,000 little millimeter dashes from the start to the end of our meter stick right here. So 1 meter, 1,000 of them make a kilometer, 100 centimeters make up a meter, and 1,000 millimeters make up a meter. So like we were saying, a centimeter is pretty small. So like 1 centimeter would be not even a half of an inch. And then millimeters are way smaller. So 10 millimeters go into a centimeter. So a millimeter is 1/10 of a centimeter. But again, much easier to keep track of than 12 inches and 1 foot and 3 feet and 1 yard and 5,400 something feet and a mile. It's all based on tens, hundreds, and thousands. Kilometers, meters, centimeters, and millimeters. All right, any questions so far about our metric meters?
No, sir.
All right. So meter is our basic unit of length. This is how we measure how far away something is or how long or wide or high something is. The other thing that we can measure is mass, which is essentially a fancy science way of saying weight. They're not exactly the same thing, but for this purposes of this class and this lesson, mass is the weight of something. So how much something weighs. So in the US, in our what's called the imperial system sometimes, we have things like pounds and ounces, right? Those are kind of the 2 main ways. If you get really, really big, you can go up to like tons, which would be like 2,000 pounds. But pounds and ounces for kind of most everyday things is how you measure how heavy that something is. In the metric system, we don't use pounds or ounces. We use things like grams and kilograms and milligrams. So some of these you may have heard of before, especially dealing with like medicine. There's a lot of medicines that come in milligrams. And that's how they're measured. That's how they measure how much of a certain type of medicine is in the pill that you're taking or whatever it is that you're taking for medicine. So mass refers to how much matter there is, essentially the weight of an object. And our base unit of mass is the gram in the metric system. So we're not dealing with pounds, we're not dealing with ounces, we're dealing with grams, which are usually represented by a little g. So again, grams and kilograms and milligrams, it's all based on thousands. So if we took 1,000 single grams and combined them all together, that would be 1 kilogram. And if we split a gram up into 1,000 equal pieces, each one of those would weigh 1 milligram. So a gram is pretty small and light. It would be about the weight of like, I don't know, a paper clip or like a couple grains of rice. Like this pen right here, this is probably, I don't know, maybe like 10 or 15 grams. So a gram is pretty light. It's a pretty small amount of weight. Obviously, you put 1,000 of them together and you get a kilogram. This is a little bit bigger. This is a little bit heftier. It's, I believe, it's like a little bit over 2 pounds, like 2.2-ish pounds. The way I always think of a kilogram, and I don't know why, maybe it's because I'm a teacher, so I'm dealing with school a lot. But if you think about like a textbook for school, like your old like history textbook or math textbook, the big ones that had the hard covers on them, a textbook usually weighs like roughly 1 kilogram. So a single kilogram would be about the weight of like a really heavy book or like a textbook or like a dictionary or something like that. And then obviously a milligram, if a paper clip is 1 gram and 1,000th of that is a milligram, milligrams are really, really small. So that's why in like a tiny like ibuprofen or acetaminophen pill, like your basic Tylenol or Advil, the pills are pretty small, but there could be, depending on the strength, 50 milligrams, 100 milligrams, 300 milligrams of medicine in that pill. Obviously, the pill is a little bit bigger because there's other stuff besides just the medicine. There's the stuff that helps it all dissolve in your stomach after you take it. But milligrams, very, very, very small amounts of weight. And then gram, also pretty small. I guess also think about like a dime or a penny. Those probably weigh like a couple grams each. And then you put 1,000 of them together and you get a kilogram. So again, gram, 1,000 of them is a kilogram, and a 1,000th, so 1/1,000th of a gram is a milligram. We got kg for kilogram, g for gram, and mg for milligram. And these all have to do with mass. These all have to do with weight. All right. Any gram, kilogram, milligram questions so far?
No.
All right, so pretty straightforward stuff so far, at least I hope that you think so. So the last thing that we're going to talk about, the last measurement, we've gone over length and distance, so how far, how wide, how far away something is. We've gone over weight, so how heavy something is. The final type of measurement that we're going to talk about is volume. Essentially, how much space does something take up? So mass is how much weight something has, how much of it that there is, but volume is how much space that something takes up. So in American units and English units, we'd use things like gallons, ounces, quarts. In metric units, we have things like liters and milliliters. So a liter is pretty small. It's about the size of a quart. So for the most part, these are things that you can actually find pretty easily, like in the grocery store, right? So a lot of sodas, like if you want a big root beer, they come in 1 liter or 2 liter bottles. So if you think about like the big bottle of soda that you get from the store for like a party or something, that's normally a 2 liter bottle. So a liter is really, really close to a quart. So if you think about like a quart of motor oil, or like the really skinny cartons that you get from the store for things like, what usually comes in quarts? Eggnog, like if you ever get eggnog at Christmas time, I don't know why, that's just what I think of because that's the only thing that I buy that's in those really tall, skinny cartons. Those are quarts, so that's about 1 liter. So a gallon has 4 quarts, which means a gallon has almost 3 liters. It's like a little bit over 3.5 liters goes into 1 gallon. So liter usually represented by either a big L or a little l. I like using the big L because it helps to distinguish it from like another number 1, because an L and a 1 can sometimes look really close to each other. So these are the base unit. They're also used a lot for liquid units. So we normally measure how much liquid is in something by liters. There's also a more kind of solid base measurement for volume, and that is cubic centimeters. So the 3 up here stands for cubed. So like, you know how sometimes if you're measuring like the area of a city, you might be talking about square miles, or when you're talking about the area of a house, you talk about square feet. The square means you have a little 2 up here. But a cube, when you're talking in 3 dimensions, you have a little 3. And so sometimes volume is also represented by centimeters cubed. I wanted to point that out because sometimes you'll see that on like the homework or other types of questions. We'll have the little cm3. That's just another way of measuring volume. It's essentially, you have centimeters for your height, centimeters for your width, and centimeters for your length. So centimeter by centimeter by centimeter gives you 3 cubic centimeters. So like I said, a liter is about similar to a quart. And so if you split that up into 1,000 little pieces, you'd have milliliters. So 1,000 milliliters, usually referred to by mLs together, gives you 1 liter. So again, milliliters are things that you might see sometimes if you have to take medicine. Like I have a, what is she now? 18-month-old. And sometimes we have to give her medicine that comes in like the little syringe that you put in their mouth. And usually you have to measure how many milliliters that they're going to take. So a milliliter is a pretty small amount of liquid. I don't know why, but I generally think of like a raindrop or like a droplet out of a little dropper bottle, or like the eye drops that we were looking at when we talked about those homogeneous mixture examples. the single drop from there would be approximately 1 milliliter.
I have a question, Mr. S. For
Yeah.
milliliter, it always has to have the L, the big L, or can I just, it doesn't matter if it's the lowercase L for ml?
Nope, it doesn't matter if it's a small L or a big L.
Okay. I was just wondering because it has it like a small m and then a capital L. So it's just like, is that really like, it has to be
No.
like that?
Not necessarily. I just like to write it that way to make it clear that it's an ml. Because again, sometimes depending on how you're writing or how you're typing, the L can look kind of like a 1. And so I'll use it to try and make it clear like this is an M and an L, not an M and a 1. But a lot of times you'll see it written as M and little L next to it.
Okay, gotcha. Thank you.
Yeah, but any sort of ml when we're talking about measurements means milliliter. That means that we're using the metric system. So when we're measuring volume, when we're measuring how much space something takes up, if it's a very small amount, we can use milliliters. If it's a little bit bigger amount, we can use liters. And especially for things when we're talking about like solid areas, solid things, we can also use these cubic centimeters, these CM3s. Means essentially the same thing. And 1 cubic centimeter is equal to 1 milliliter in terms of their actual space. So there's a fun little kind of handy dandy conversion right there. So we've got our length. We're using meters and kilometers and millimeters and centimeters. For weight, we're using kilograms, we're using milligrams, we're using grams. And for volume, we're using liters and milliliters. So again, this is how all scientists across the world take measurements, take observations. Even in America, scientists do not use the English system or the American system. So in a science lab, you'll never see anybody recording things in pounds or in feet or in like square inches. It'll always be using these SI units, using these metric units, some form of meters, grams, or liters. So whether you're in, again, whether you're in America or Germany or Japan or South Africa, all scientists use this same standard unit of measurement. It makes things easier because, again, converting between the different sizes is much easier than the American way. Most scientists around the world naturally use this because their cultures use these systems to measure things. And it makes things easier when we're talking from one scientist to another, even if we come from different places. We know what type of work that they're doing, and it's easy for us to wrap our head around as scientists because we're all using these same units, these same metric units. All right, so before we move on and start talking about how to convert between the different sizes, anybody have any more questions about meters, grams, or liters?
No, sir.
All right. So, like I was saying, one of the things that scientists really like about the metric system is it's easy to convert between the different sizes of units. So if I have meters, it's very easy for scientists to convert those to kilometers or to millimeters because it's all based on these factors of 10, tens, hundreds, thousands, which are very easy for us as humans to deal with. So today, I'm going to show you guys and work with you guys to show you kind of a quick and easy way to do these metric conversions. And it's using something called the ladder method that I really, really like and I really think is very useful when learning about these types of conversions. So here is what is called the metric ladder, or the metric stairs, essentially. So we have our basic unit in the middle here. And so our base units are things like meters and grams and liters. And then we can go to the smaller units over here. So like centimeters and milliliters. So our centi and milli are down here. And then our bigger units, our kilo units, are up here at the top. So there are some in between ones too, like hecto and deca and deci, but we don't really use those a lot in science, and we're not really going to talk about them a lot in this class. So you don't really have to know about these specifically, just know about them as kind of these steps on the ladder. So there's kind of three basic steps to the ladder method. So we're using this method if we have things of one size, of one unit, and we want to convert them into a different unit. So say we want to go from kilo units to basic units. Like we have kilometers and we want to know how many meters do we have. The first thing that you have to do is determine your starting point and also your ending point as well. So for example, if I want to convert between kilometers and meters, my starting point is kilometers, which is these kilo up here. And my ending point is meters, and meters are a basic unit right here. They don't have any extra little starting prefix like centi or milli. So if they don't, if it's just meters or grams or liters, that is one of our basic units. So we're starting from kilo and going to meters. The next thing that we have to do is count how many steps or how many jumps does it take to go from one to the other. So we're going to count the number of steps or jumps to go between kilo and base unit, between kilo and meter in our case. The cool thing about counting these steps is that then we're going to go to the number that we're converting and move the decimal point of whatever our starting number is, the same number of jumps in the same direction. So what that looks like is something like this. We have 4 kilometers, and I want you to tell me how many meters are in 4 kilometers. First thing that we have to do is figure out our starting point and our ending point. Starting point is kilometers, and kilometers are right here in kilo. Ending point is meters, which, like I was saying, is a basic unit right here. So in order to get from kilo meters to regular meters, we have to go 1, 2, 3 jumps to the right on our ladder. So going from kilo to basic is we're moving to the right. Okay, we're going to the right side. And it's going to take us 1, 2, 3 jumps to get here. So that's what these little bumps up here are referring to. We go 1 jump from kilo to hecto, 2 from hecto to deca, and 3 from deca to our ending point, our base unit. So 3 jumps from kilo to the right to go to meters. So our starting number was 4 kilometers. So we have to move our decimal point 3 jumps to the right. So on most numbers, or on all numbers, if you don't have the decimal point already listed out, like it's not 4.2 or something like that, it's just 4. So the decimal is right here at the end of our 4. So down here, you can see, sorry, the 4 gets covered up by this weird little thing. But we take our decimal point and we move it 1, 2, 3 jumps to the right. That leaves some empty spaces here. And we're going to fill in those empty spaces with zeros. So we started with our decimal point at 4. And then we moved it 1, 2, 3 jumps to the right. We fill in those 1, 2, 3 empty spots with zeros. And our new number is 4,000. So 4 kilometers is 4,000 meters. We started off with the 4. We knew we had to move 1, 2, 3 jumps to the right. So we moved our decimal point 1, 2, 3 jumps to the right, and we filled in those 3 empty spaces with zeros. So we turned our 4 kilometers into 4,000 meters. So that is how you use the ladder method. You have a starting point, you have an ending point, you count the number of jumps between them, and you look at the direction they're going, and then you move the decimal spot on your number that many jumps, and then fill in the blank spaces. So to go from kilo to meter, we moved our decimal spot, our decimal point, 3 jumps to the right, and we filled in the empty spaces caused by those jumps with 3 zeros. So we took our 4 kilometers to 4,000 meters. All right, we're definitely going to do a bunch more examples of these before we wrap up for today. But does anybody have any questions so far? Anything anybody is confused about with the ladder method and conversion of units so far?
No, I don't.
All righty, so let's go look at some more examples of this. So I like these ones because it already kind of shows you the answer, so it'll show you where I'm going to go. So for a really simple one, let's look at this first one down here. This says that 1,000 milligrams should equal 1 gram. So I want to check if that's right. So our starting measurement is milligrams. So milli is our starting unit down here. Our ending unit is grams, which is one of our basic units. So grams is right here. So to go from milli to grams, I'm going to go 1, 2, 3 jumps to the left, right? I'm going from the left from milli to grams, and it's going to take me 1, 2, 3 jumps to get there. So our decimal point starts at the end of our number if we can't see it. So it starts right here. And then we're going to move that decimal 1, 2, 3 jumps to the left. So now instead of being 1,000, it's 1.000, which is the same thing as just straight up 1 gram. All right, so started at milli, went to grams, 3 jumps to the left means we moved our decimal spot 3 jumps to the left. Sometimes you'll have a starting value that already has the decimal listed out for you. So we're starting off with liters, we have 1.6 liters, and this is telling me it's supposed to equal 1,600 milliliters. So let's see about that. Liters is one of our base units, and milliliters is down here. So we're going to move to the right, going from liters to milliliters. Start off with liters, and we're going to go 1, 2, 3 jumps to the right. So we take our decimal point, which is already listed for us in between the 1 and the 6 here, and we're going to go 1, 2, 3 jumps to the right. So, okay, decimal point here. 1, 2, 3 jumps to the right. So now the 6 is 1 jump. There's an empty jump, so that's going to be a 0. And a third empty jump, which is going to be another 0. So we've gone from 1.6, so 1.6 looked like this. Then we moved it 1, 2, 3 to the right, and now it's 1,600 milliliters. So 3 jumps of the decimal place to the right, because 3 jumps from liter to milliliter to the right means that our 1.6 gets converted into 1,600 milliliters. Right, I'll do one more kind of example one for you guys, and then I'll have you guys help me out with some examples. So we have our base unit, and this one we want to go from meters to kilometers, and this is telling me that 250 meters is the same thing as 0.250 kilometers. So I want to double check and make sure that's right. So meters is one of our basic units, so we'll put that right there. Kilometers is way over here, our kilo units. So our starting point is meters, our ending point is kilometers, and we're going to go 1, 2, 3 jumps to the left. So in order to go from meters to kilometers was 3 jumps to the left. So we're going to have to move our decimal point 1, 2, 3 jumps to the left. So let's see what that looks like. We have a whole number here, which means that our decimal is here right at the end. And then we're going to move it 1, 2, 3 jumps to the end. So now instead of being at the end of our number, it's 1, 2, 3, right at the front of our number. So in fact, that is correct. 250 meters equals 0.250 kilometers. We moved 3 jumps to the left on the ladder. So we had to move our decimal point 3 jumps to the left on our number down here. All right, so we'll do a couple more examples. I have you guys help me out with a couple more examples to kind of make sure everybody's got it. But does anybody have any other questions so far? Anything about this process that's still a little bit confusing? You're not sure how I'm getting to different parts?
No, I don't.
All right, so for the next part, since I'm going to have you guys, or I'm going to kind of show you guys the actual, like if we were writing it out. I'm going to open up a whiteboard. And make sure all the sharing settings get turned on correctly. Just One with the link can view. Okay. Cool. All right, so here we have my crappy reconstruction of our ladder, but it still has all the important parts, and that's the main thing here. So let's see, where is good examples here? All right, oh, this is a good one. We have 480 centimeters to meters. So we have 480 centimeters. And I want to know what that is in meters.
It will be 4,800 meter.
Not quite. You're on the right track, although you might be going in the opposite.
4.8.
Oh. So we're going from centimeters to meters. So which one of these boxes is our starting point on our ladder here?
The base?
So the base is actually our ending point because that's meters. So meters is our base unit. So that's where we're going to end. It's right here. Our starting unit is centimeters. So where are we going to start on the ladder?
Between on the right.
Mm-hmm. On the right. So we got base, we got C, we got M. Which one do you think goes with centimeters?
C.
C. This is our starting point right here. So cm, centimeters, is our starting point. Meters is a base unit, so that's our ending point. So what direction do we have to travel to get from C to base?
We go to the right one time.
Not the right. So this is milli down here, and we're going here. So we're going to the left. So we're starting at C, and then we got to go here and then here. So how many jumps do we have to take from C to base?
2.
Two jumps. So we're going to take 2 jumps to the left. So our point starts here. And then we're going to take it and we're going to go 1, 2, to the left. So now we don't have 480 centimeters anymore. How many meters do we have?
4.80.
4.8, well, 80, but it's fine if we leave the 0 off. 4.8 meters. So 480 centimeters is the same thing as 4.8 meters. We figured out the starting point. We figured out the ending point. We made 2 jumps to the left. And so that's what we did with our decimal point right here. 2 jumps to the left. All right, very nice, very nice, very nice. Let's do that again after I go through and Erase everything. Yeah. Yeah. That for now. And erase all these guys. All right. Let me look up another good example here. Okay. So I have 5.6 kilograms. And I want to know how many grams do I have? 5.6 kilograms, and we're going to turn that into grams. So first things first, what is our starting unit? What is our starting box on our ladder here?
On the left,
Mm-hmm.
in the top K,
Yeah,
and going
our
to
K.
the right 1 to 3 times.
Oh. So K is our starting point. So I'm going to put an S there for starting. And then gram. So where, I think Dewey was saying it a second ago, but where does our gram fall in? What is gram classified as?
On the base,
Yep, gram is one of our base units, just like meter and liter. So this is our ending point. I'm going to put an E for end. So start with kilo, end with base. So we're going to go boop, boop, boop. So how many steps is that? How many jumps?
3,
3 jumps. And what direction are we going in?
but 3 more 0.
So did we go to the left or to the right?
To the right.
Correct. So to get from kilo to base, we went 1, 2, 3 jumps to the right. So that's what we're going to have to do with our decimal point down here. So if I have 5.6, I'm going to move the decimal point 1, 2, 3 jumps to the right. And then what do we fill in our empty spots right here? What number goes here?
0.
0. So 1 jump for the 6, 1 jump gives us a 0, and jump number 3 gives us a second 0. So how many grams is equal to 5.6 kilograms?
5,600 gram.
5,600 grams. Precisely. So 5.6 kilograms is equal to 5,600 grams. We figured out our start. We figured out our end. We moved 3 jumps, 1, 2, 3. And so we moved our decimal point 1, 2, 3. Filled in those blank spots with zeros. So 5.6 becomes 5,600, 5,600 grams. All right, very, very, very nice. Good job, especially shout out to Dewey. Nice answers there. Let's do one more to kind of bring it all together. All right, let's see. What's a good final example that we can wrap up with? Ooh, I like that one. All right. So I have 8 millimeters. And I want to know how many centimeters is that. So we're going to convert 8 millimeters into centimeters. So what is our starting box? Where are we going to start with our conversions on the ladder?
The right ladder and start at M.
This little m down here is for milli. So this is going to be our starting point. And then what are our ending units? Where are we going to end on our ladder here?
We go into the left one.
So which box is that? What letter does it have in it?
I think C.
C for centimeters. This is our ending unit. So we're starting at milli and going to centi. Millimeters to centimeters. So we start here and go whoop, right here. So how many steps did we take?
1.
And what direction did we go, left or right?
Left.
1 step to the left. So meter or millimeters to centimeters is 1 step to the left. So I'm going to take my decimal that's right here and move it 1 step to the left. So they'll end up being over here. So how many centimeters are 8 millimeters?
0.8.
0.8, exactly. We'll make it a little bit fancy. 0.8. So 8 millimeters, we move the decimal point 1 step to the left because on our ladder, we had to jump 1 step to the left. So 8 millimeters becomes, with the decimal in front, 0.8 centimeters. So we figured out our starting, figured out our ending, counted the steps and the direction, and then moved our decimal point in that many steps in that direction. All right, excellent work. So now that we've done a whole bunch of examples, kind of all together, does everybody feel pretty comfortable with these conversions? Anything that anybody still has any questions over?
No, sir.
All right. So let me go back to our notes here. There we go. That's what we're looking for. There we go. All right. So your assignments for today and tomorrow are fairly straightforward. So for today's assignment, it's all about just over the units. So the meters, liters, grams, and all the variations in between. So there are a couple different parts. The first part I'm going to give you a unit and a little abbreviation for a unit. And I want you to tell me, does this refer to length, mass, time, which is one that we didn't really talk about in the notes, but everybody across the world uses the same system of like seconds, minutes, and hours for the time. And generally, seconds are represented by like a little s, minutes are like MIN, and hours are H or HR. Everything else is ones that we went over in the notes. So for each one of these measurements, ML, S, KM, G, CM3, MM, I want you to tell me, is this a length measurement, a mass measurement, a time, or a volume measurement?
Oh, thank you for explain. If you don't give me no S is the time, I didn't know what is it.
Yeah, that's why I figured I'd bring it up. One thing that we didn't really talk about specifically in the notes. And then for the next part, I'm going to list out the full name of the measurement, and I want you to tell me what symbol goes with it. And so the symbols were things like the kg, the L, the mm, the cm, stuff. So for milliliter or milligram or kilometer, I want you to tell me, what is the abbreviation for this? What's the 1 or 2 letter abbreviation that you would use to refer to kilogram or centimeter or liter, stuff like that. And then finally, I have a couple pretty simple fill in the blank questions. So I want you to tell me which of the units that we talked about today fits best in the blank right here. And so the one thing that people still try to do is they try to write in things like pounds or gallons or stuff like that. Don't do that. Those are American imperial measurements, and that's not what we're talking about here. We're talking about metric measurements, SI units. Each one of these blanks you should be able to fill in with like gram or milliliter or kilogram or centimeter, something like that. Whichever measurement best fits whatever scenario is being described. Like how heavy is a paperclip, or how big is a housefly, or how heavy is a bowling ball, stuff like that. So that is for today. A lot of questions, but they're all really, really short and easy. And then tomorrow is a little bit lengthier in terms of questions and difficulty, but it basically is just a lot of examples of the SI conversions that we talked about at the end of the day today. So for each one of these, I'm going to give you a measurement, and I want you to convert it into this final form. So this first question, how many grams are 1,000 milligrams? How many meters are 14 kilometers? How many kilograms are 27 grams? So for each one, you'll fill in your answer based on using that ladder method. So starting point, ending point, how many jumps, moving the decimal that many, and filling in any of your blank spaces with zeros if you need to.
Is this tomorrow's homework or is it today?
Yeah, this is Wednesday's assignment.
Oh, okay.
So yeah, today's homework is just the one where you're telling me about the different units. All right. Anybody have any final questions about the assignments that we went over today? Or anything from the notes that we went over today as well? There we go. All Righty, guys. Well, as always, if you do ever have any questions or you get to some point that you're stuck on, please do not hesitate. You can send me an email. You can shoot me a text message. You can leave a comment on the assignment or somewhere on the Google Classroom, and I will do my best to get back to you as soon as possible. Thank you all so much for being here today. Have a good rest of your Tuesday. Make sure you log on and do that Wednesday assignment to get attendance for Wednesday. And I hope that I will see you all back for our next IPC class on Thursday.
Bye, Mr.
Thank
S.
you. Have a nice day.
See you all.
Bye.
Have a
Bye.
good one. See you guys.